Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with numbers 1, 2, and 3 in your homework here over electric potential and DC circuits. So let's see number 1. It says an evacuated tube uses an accelerating voltage of 53 kilovolts to accelerate electrons to hit a copper plate. So basically what's happening is we have electrons and they must be in an electric field. I'm going to have the electrons accelerating to the right. So the electric field actually must point this way. Whoops. Yeah, that's correct. Because the electric field direction, remember, is based on the force direction on a positive charge. And then the equipotentials run this way. And the 53 kilovolts is the difference in potential, the delta V between these. Now yours might say a different number than 53. And I'm going to go ahead and write this as 53,000 volts. So this is a basic work energy problem. If I write out the work energy theorem, we call this position 1 and this position 2. And we write PE1 plus KE1 plus work equals PE2 plus KE2. Okay. The electrons presumably start from rest. It doesn't specifically, I don't think, say that, but I'm sure that that was the intention. That makes the KE1 0. The work term is 0 because the only force acting on this is the force produced by the electric field, and I'm going to take that into account using electric potentials. Now, you can always set a datum in these problems. I'm going to go ahead and put the datum, actually, we'll put the datum here. So what we're doing is we're saying that the electric potential here is 0, and that makes the electric potential here 53,000 volts, which remember is a joule per coulomb. I'm going to put volt, but remember that's a joule per coulomb. The electric potential is how much energy you have per unit charge. So if we go ahead and put the datum here, we call this 0 electric potential. This becomes a 0, this becomes a 0, the work term is 0. Potential 2 is the charge of an electron. That's the fundamental unit of charge, negative 1.6 times 10 to the minus 19th coulombs, times, I'll put potential 2. And this is potential 2 right here. And then the KE2 is going to be 1/2 mv squared, where this mass is going to be the mass of an electron. So that should hopefully get you through problem number 2. I'm sorry, problem number 1. Problem number 2, let's see, a bare helium nucleus has 2 positive charges and a mass that's given. So it says 2 charges, so the charge that they're talking about is 2 times 1.6 times 10 to the minus 19th coulombs, or in other words 3.2 times 10 to the minus 19th coulombs. And the mass is given. I'm not going to even bother writing it out. Calculate its kinetic energy in joules at 2.4% the speed of light. So the speed of light is one of these fundamental constants of nature. It's usually denoted with the letter c, and that's equal to 3 times 10 to the 8th meter per second. So it says 2.4% of that, you would take 0.024, right? That's 2.4% written as a decimal, times this value to get your speed. I'll just call that v. Then the kinetic energy, which is what it asked for, is going to be 1/2 m times this v squared. Part B, where it says what is the energy in electron volts. So that is a question about unit conversions. There's 1.6 times 10 to the minus 19th joules in 1 eV, or 1 electron volt. That's a consequence of just how the electron volt is defined. So for part B, just do a unit conversion. Part C, what voltage is needed to obtain this energy? So that's another work energy type of situation. What they're saying, oops, let me clear this out here, is we have this particle. It's being accelerated by an electric field, right? And we have some sort of electric potential here, but we don't know what. Let's call it potential 1. And here's the particle sometime later. It's moving with speed. Let's call that v. Again, that's a velocity in meter per second, but it's at a new potential, potential 2. And if we write out the work energy theorem, PE1 plus KE1 plus work equals PE2 plus KE2. And remember, electric potential is defined as potential energy per unit charge. So your potential energy terms are equal to charge times potential. So the PE1 term we can write as charge times potential 1. Starts from rest. Only force is the Coulomb force, the force created by this electric field, which we're taking into account with the potential energies. Charge times potential 2, 1/2 mv squared. And if you read the question, it says what potential difference or what voltage would be needed to obtain this energy. If you solve this for like potential 1 minus potential 2, so write it, just solve it so that it looks like this, equals some number. This would be the voltage needed to obtain that this kinetic energy. So that hopefully will get you through this problem. I hope that this helps. Have a great day.